I did not get it. Yeah, I'm on page 35, but we're supposed to do it.
Yes, we're supposed to work on page 35.
What's 260 plus 260?
That's crazy.
720.
Okay, so give me one more minute on page 35, and then we're going to talk about it. 360 plus 360 is 720. He's right. That's what he said, right?
No.
Oh, okay.
That's not what the question said.
Oh, it's not what the question's asking. 100%.
It's not asking for a number.
Yeah, I know.
So you said 720 is the answer, but it's not asking.
Yeah, I know. I said all the angles add up to 720.
All right. Our ICANN statement is determine the measures of the angles formed when the parallel lines are intersected by a transversal. All right. So we are getting into parallel line proofs. I will tell you this much. There is a proof on your topic 2 test. All right. So keep it in mind. I know proofwriting's amazing. I love proofwriting too. Some are, some aren't, just like the last test. All right, so here is the explore and reason. It says the diagram shows 2 parallel lines cut by a transversal. Note the red arrows show parallel lines. You guys see this right here where you have these 2 arrows? When you are representing parallel lines, you need arrows that go in the same direction. If you have multiple parallel lines, you could always add something like this. Okay, you can go the other direction too, that is fine. But just keep that in mind when you're looking for parallel lines, look for those arrows, all right? So it says, look for relationships. What relationship among the measures of the angles do you see? Someone give me an idea. Go ahead. You see vertical angles. Very good. Anything else that we see? Good. We have exterior angles. Okay, anything else? We have supplementary angles. Yep. Anything else? Go ahead. Linear pairs. Yep. All of these are great answers. Is there anything else anybody wants to add? Okay, so here is a bit more of a numerical answer. It says the measure of each angle is either 58 or 122, if you look like right here. So each pair of angles is either congruent or supplementary. How did I get the 58 and 122? I just used a protractor. The angles that form a linear pair are supplementary and the vertical angles are congruent. This is kind of the big thing. When you are dealing with parallel lines cut by a transversal, you are only going to have 2 answers. Maybe 1, depending if they're right angles. Okay? So in this case, when I use a protractor to find the 58 and 122, those have to add up to 180 also. Okay? Questions on that? Okay, suppose a different transversal intersected the parallel lines. Would you expect to find the same relationship with the measures of those angles? Yes. The measures of the angles might change because the slope of the new transversal might be different than the original one, but the pairs of angles should still be congruent, supplementary, or both. Those are the big deal. Congruent or supplementary. Those are the 2 key words for this, okay? Yes.
What period is 115?
7th, I think. What does that have to do with this right now?
Oh, yeah.
Yeah, we do. Okay. All right. Anybody still writing? Show hands. Okay. Another minute. Okay, on the next example, cross out B. We're not going to do B. We're just going to do A, and we're just going to use this to identify. You might need to, I think this is the same picture. You might need to draw, yeah, this is the same picture. You might need to draw this picture by example 1, so why don't you do that real quick. Just draw it in the blue area because you're going to have to do some writing. The picture right here. They're going to reuse this picture in the next example, so draw that in. We're just going to do the try it. And make sure you have the numbers. Definitely make sure you have the numbers, okay? Okay. All right, so what we're going to do is we're going to identify some angles here. All right, so which angle pairs include the named angle? So what we're looking for is same side interior angles. The same side interior angles are in between the two parallel lines and are right here or right here. Alternate interior angles are usually, again, between the two parallel lines, but they cross the transversal. Corresponding angles means that we have like 1 and 6, 4 and 8, 2 and 5, 3 and 7. Like if I cut this here, grab this point, put it on top, you would have those corresponding angles. Vertical angles, we already know those go across, and then linear pairs. Now we're basing all of this off of angle 4. All right, so we're basing it all off of this. So if we're going to talk about same side interior angles, the same side interior angles will be what? Who could tell me? Good. It's going to be 6. Yep. So just write, provided it works. Here you go. So same side interior angles, it's paired with angle 6 if we're talking about 4. How about alternate interior angles? Good. 5. Very good. Who's got corresponding for me? 8. Very good. Vertical angles? So what would be vertical to 4? Good, Kira. 2. How about a linear pair to 4? 3. Is that it? 3 and 1. Very good. So 3. But wait, there's more. 1. Does everybody see that? Why 3 and 1 would be linear pairs with 4? Okay. Good. Now, the things you need to know about when it comes to these things. Same side interior angles are supplementary. Alternate interior angles are congruent. Corresponding angles are congruent. Vertical angles you already know are congruent, and then linear pairs are supplementary. After the lesson, sure. Okay, so number 2 actually has 2 parts, even though they didn't give it all to you guys for some reason. So you're going to have to write down B. But is anybody still writing down this? Awesome. Okay. We're going to skip this. Okay. So they added part B later, and I think it's a really good example. So make sure you write down part B, like cut type 2 in half. Okay. And you should be okay. It couldn't hurt. The numbers are a little different, so yeah, I would probably draw the diagram too. So I'll give you guys a minute to do that. I know it's a lot of writing today, guys. Sorry. I wish they would. I'm trying to figure out a way to print stickers for this stuff. So you guys can just grab a sticker. You know what I mean? Not as much as you think. Huh? I know, I can't afford them. I need the school to pick this one up. No, I think there's a way, like, if we get, like, they actually sell, like, ones that run through, those pages that run through printers. You know what I mean? I would like to do that. And, like, buy a bulk of, like, just stickers and, like, have the copy clerk print them out for me so that this way you guys can just, like, whoop, add it in, you know? I can't afford to do that, though, on my own. I'd love to, but. Okay, anybody still writing this down? I'd like to go through it. Alrighty, so let's take a look at part A. So it says, if the measure of angle 4 equals 118, what is the measure of the other angles? So angle 4 is 118 degrees, okay? Now that means I know that angle 2 is also what? 118. What else is going to be 118 here? Angle 6. What's another one? Good. 8. Okay. What does that leave us for the rest of these angles? Who could tell me that? What'd you get? 62. So 3 would be 62 because that linear pair, that's vertical. Again, another linear pair, and that's vertical. So if you want a clearer picture than Mrs. Smith's sloppy handwriting, there it is. Okay, questions on that? Okay, so let's take a look at letter B. So it says, if the measure of angle 2 is 9x minus 12, so I'm going to write that in, 9x minus 12, and the measure of angle 4 is 6x plus 30, find the measure of angle 5. So the first thing is, what type of angles do we have here? They're vertical, so that means these two are congruent. All right, so I'm going to set this up as 6x plus 30 equals 9x minus 12. When I solve for this, what do I get for x? Good. 14. All right, but am I done? Am I? No, because they're asking us specifically for the measure of angle 5. And we know the measure of angle 5 is going to equal which one do you think? Well, what do you think we should do first? Let's put it that way. Good. Find the measure of angle 4, okay? So could I use angle 2 as well? Yeah, I can use either one. It doesn't matter. All right, so we're going to have 6 times 14 plus 30. That gives us the measure of angle 4. So what does that equal? Calculators. In a world of technology, we need calculators. What is it? Was it 118? I didn't get 118. Yeah. 114. Yeah. Okay, so 114 is the measure of angle 4. Now, what am I going to do with this in order to find angle 5? Good. Very good. So the measure of angle 5 is going to be 180 minus 114, which gives us, bum-ba-da-dum, 66 degrees. Questions on that? All right, we've got 2 more examples, and guess what? They're proofs. 2 more examples. We love proofwriting in this class. All right, just so, again, you don't have to see Mrs. Smith's sloppy handwriting necessarily. Boom, there you go. There is everything. Anybody still writing? Going once, going twice. All right, let's head. All right, we're going to skip this for, whoop. We'll skip that for right now. It's going to take forever to get through. Let's get to here. All right, so let's talk about this. We're going to prove the corresponding angles theorem. Now, here's what you need to know. Everything you are learning right now, you are given parallel lines. Okay? So the thing you really need to take away from this, if given parallel lines, then you are usually proving angles. That's going to be an important side note when we get to 2-2. So you guys should see try it 3 right now. All right, so what do I usually start with here? I always start with what? The given, right? So I'm given that the measure of these parallel line, I'm given that M is parallel to N. Okay? Now, because I know that these are parallel, and not that this has anything to do with the fact that they're parallel, but I know 1 and 3 are a linear pair. Someone tell me what do I have there? Go ahead. Definition of a linear pair. Very good. Okay, so if I have a linear pair here, what do I know about the measure of angle 1 and the measure of angle 3? Go ahead. They're not congruent. They're supplementary, right? So that's the next one. Okay. What else is supplementary here? What else is supplementary here? Go ahead. Do you know? Evan? 2 and 3. All right. So my next step is that the measure of angle 1 plus the measure of angle 3 equals 180, and the measure of angle 3 plus the measure of angle 2 equal 180. But there's 2 different reasons here. What's the reason for number 3? Good. Linear pair theorem. Very good. What's the reason for part 4? Not substitution. Nope. Nope. It's a new one. It's one of the parallel line ones. Which one do we go over? Same side interior angles postulate. Yup. See, here's the thing. It's not that you guys knew that they were 180. You guys knew that they would add up, right? That part is good. But if you look right here, are these 2 angles split up in any way? Like, is there something running through them to make them a linear pair or anything like that? No. So you have to use the same side interior angles postulate to use that, okay? Questions on that so far? All right, now what's my next step going to be? Someone tell me. Substitution, very good, okay? And that's going to give me the measure of angle 1 plus the measure of angle 3 equals the measure of angle 3 plus the measure of angle 2. So there's your substitution property. Now we're left with the measure of angle 1 equals the measure of angle 2. Why? What happened there? Not transitive property. Close though. Subtraction property of equality. Excellent job. And now I'm stating that angle 1 is congruent to angle 2. Why? It's not transitive. Was it? Definition of congruent angles. Yep.
What did I say?
Now, over here, right here, you guys see substitution property. This could easily be transitive property too, because you have the matching pair right here, right? The rest, though, there's no getting around it. Yes.
So like, I could just skip number 5 and say number 6 is transitive.
No. You can't skip it. I'm just saying you can use substitution or transitive here. You can't, don't skip.
What's the difference?
The difference is, remember that there's always, like, for the transitive property, you have like that matching pair that makes the two equal. Substitute, and that's why you can kind of flip-flop those sometimes between substitution and transitive. However, not everything that's substitution property can be transitive property. Like if I physically just took, like, I don't know, the measure of angle 3 and substituted for measure of angle 2, that's not going to be transitive. That's just going to be substitution. Does that make sense? Yeah, Evan, you had your hand up?
Yeah, so what defines substitution property?
Well, in this case, substitution property works too. If you are physically taking, like I just told him, let's say we had like the measure of angle 1 is equal to the measure of angle 3. And I took this and physically substituted in for the measure of angle 3. That is straight substitution. You cannot use transitive property there because you are physically putting it into something else. Transitive property is where you have these pairs, so that can kind of go either way. It could be substitution, it could be transitive. Does that make sense? And either one technically works there. So if you want to just stick straight substitution, you can. But just don't be surprised if you see transitive property somewhere down the line. Does that make sense? Okay. Questions on this? All right. Anybody still writing? All right. We have one more example. And then again, another proof. I know you're so excited. I am too. I love my proofs. All right. So it says, given AB is parallel to CD, prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. So essentially, what do we have here between angle 1, 2, and 3? Who could tell me? What? We have a triangle. So we need to get something that equals 180 degrees, right? All right. So again, I am starting with my first given statement that AB is parallel to CD. I thought those were fun. Sorry. But you are looking at the screen quite intently, right? Yeah. All right. So the next thing I'm saying is that the measure of angle 1 plus the measure of ACD, so A to C to D equals 180 degrees. What is that? What is 1 and this whole thing right here? They're definitely supplementary, but what's the rule? No. It's not two right angles. No. They're same side interior. Guys, if you take, I'm going to highlight this for you a little bit. If you look right here, and here's the transversal, or you know what, better yet, sorry, wrong transversal. This and this and this is the transversal. You have that and that as same side interior, the whole thing. Okay, that's 3 and 4 combined. So we have same side interior angles theorem there. Now, one thing about, yeah. It is a postulate. Our old book called it a theorem, so that's a typo. So that should be postulate. Sorry about that. Yeah, the old book called the corresponding angles the postulate, so the books are a little different. Okay. So now for my next thing. Now I'm trying to I have measure of angle 1, I still need the measure of angle 2, and I need the measure of angle 3. If I look at ACD, I see that angle is these two combined, right? So what do you think I'm going to apply there? No, not combined like terms. Not substitution. ACD, so this angle right here, is equal to the measure of angle 3 plus the measure of angle 4, which is what? It does not say anything about it. Angle addition postulate.
Oh no. What was she
I
gonna do?
answered that first. You got it from me. I'm just saying.
That's okay.
It's not true.
Okay, so that's the angle addition postulate. And then what we're doing is we are taking the measure of angle 3 plus the measure of angle 4 and substituting it into the measure of ACD. So this gives us the measure of angle 1 plus the measure of angle 3 plus the measure of angle 4 equals 180 degrees. And that's through substitution. Do you guys see the difference between that and transitive property? See how I physically took this and put it inside this equation? That is straight substitution property. You cannot use transitive property here.
Yo.
Okay, so let me get a different color. Now, if I look right here, again, here's our parallel lines, and here's our transversal. What else can we get out of this for angle 2 and angle 4? Close. And that is not called opposite interior angles. It's called, yes, alternate interior angles. Very good. All right. So, and that means alternate interior angles are what? Congruent. And that means if we want to set them equal to each other, we're going to have to apply what? So they're congruent. We're trying to get the measures equal. What do we apply there? Definition of congruent angles. Good job. All right, so here's the next two. And there's that. Please stop touching each other.
Yo.
Okay. Last but not least, we're going to take this. We're trying to get measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. And we have 1 and 3. We're going to take the measure of angle 2 and substitute in for... Oh, there's a typo. No one caught it. This is supposed to be 4. There we go. Typo. Typo. I'm going to fix that right now.
That's not how it works.
No, it does. It does. It literally makes no sense.
And what the?
No, listen. 2 snaps.
That was one. No, it wasn't. No, it wasn't.
2 snaps.
Or do you use your index or
I use these.
it's like a.
Yeah, it's like a.
I'm always doing the one. So.
This is how I snap normally with one snap.
Oh,
Everyone calls me Mary.
All right. So I am taking this measure of angle 2 and substituting it into the measure of angle 4 here. So that is our substitution property. All right. So we're having the measure of angle 1 plus the measure of angle 3 plus the measure of angle 2 equals 180. Now, remember when I said before that we have to make it look exactly like how they want us to prove it, right? That means 2 has to come before 3. It has to go in numerical order. It is not symmetric property here, though, because we are not dealing with a flip around the equation sign, the equal sign. It's not transitive. It's something you probably haven't seen in a while, so that's why I'm going to give it to you guys. It's the commutative property of addition.
No, I've never heard that.
It's been a while, I know. What that means, the commutative property of addition, there's also one for multiplication. What that means is it doesn't matter how you add, you will get the same answer. So you could flip around the terms using that, okay? My son, I think, learned it in like 4th or 5th grade. So I think so. It's been a minute. It's the one where they kept giving you like parentheses and like flipping them around and then still getting the same answer.
You are wild. In 5th grade, man. Dude, I don't even know that.
Commutative, it's like community. You're allowed to take everything and mix it up.
Bro,
It really is.
I barely knew what addition was.
It's something with and the.
All right, questions on this that I can address for you guys. Is there anything?
I'm the original, bro. That means
Okay, so I do want you guys to work on, this is just a reminder. I do have a half sheet for you guys for these problems. I'll get them to you in just a few minutes. So this way you have it. But one thing I do want you guys to do is work on these problems 1, 2, 3, and 4, please. It's on page 38. Because we're skipping 5, so. Okay. No.
And you haven't seen my AirPods in here?
If I did, I'd have them in my drawer. Yes, I would, 100%. Because I don't want anybody's earbuds. That's kind of gross.
Like confidential correspondence.
I have my own phone. I don't really need them. But if I do see them, Evan, I'll let you know. Sure. So I didn't know. Bless you.
Huh? Oh yeah, and money repair. Bro, I was like, bro, I was joking.
Yeah, we've been at it.
Oh, you did?
That was like the first thing we did.
I like texting people just ask them if I left it.
Not right now. Yeah, at passing period you can. Okay, let me get you guys those sheets.
Corresponding, right?
Yeah, probably.
Corresponding and vertical.
I didn't read number 2, so it's no. Oh, there's 3 that are.
Oh yeah, and the alternate side of it.
Yeah.
Hear that? They're a movement. Oh my god. Every time I've spelled side today, I spelled it without an E. Every time I've spelled side, I've spelled it without an E.
Sid?
Yeah.
Sid.
What?
The W. Oh yeah. I know.
Is it still this room?
Okay, guys.
What era does you make?
I'm gonna pass these out to you guys. We'll go over these answers in just a few minutes.
The lines are parallel.
There.
So
Not parallel.
Again, I wouldn't
Not
lose these
corresponding.
sheets. I think they will definitely help you. All right.
I'm really mad at Leo right now.
There's a lot of
We
we got a lot less stuff than in topic 1, so you're probably not gonna be getting one of those like bulk sheets unless we find one somewhere. Because right now it's not in Savant. Whatever.
Savant, bro. It's way up.
I hate ass. It's ass.
Savant, bro. Like, where are we from?
Who's that one girl? Who? I don't like the ass.
It sounds like
Megan
a
Thee Stallion. What'd you say?
Megan Thee Stallion.
No, he said not Schweck.
Yeah, that's why Benson.
Bro, he had to add that.
Why is that the first thing you thought of? Why is that the first analogy you thought of for sadness?
Sounds like a medicine. Sadness.
No, no,
I like it.
It's
I don't like it. I miss Pearson. Pearson was good.
All
All right, how we doing on these? You got like another minute to finish. We're gonna go over them. Yeah.
You guys have the third go over. I got the who?
Well, no, this is physically proving the corresponding angles theorem, so that's why we couldn't use corresponding. Does that make sense? All right, let's talk about one. So it says, what angle relationships are created when parallel lines are intersected by a transversal? What we got? What are those 4 relationships? Anyone? It's like from example 1, guys, or example 1, I think. Yeah, example 1. What are those angle relationships?
Vertical, corresponding, same side interior, alternate side interior, and linear pair.
There we go.
Smart, boy.
Corresponding, alternate interior, alternate exterior is another one you guys are going to note. And same side interior. Very good. All right. When a transversal intersects 2 parallel lines, which angle pairs are congruent? In this case, it's the alternate interior angles, alternate exterior angles, corresponding angles, and vertical angles. All those are congruent. Okay, so number 3, what error did Leah make? Yes. How do you know? Yeah, the lines are not well, it's not even the fact that it's not straight. Do we always trust the picture? We trust the math behind the picture. So it's not the fact that they're not straight. It's the fact that they don't have what? They don't have those arrows. Yeah, that's a big deal. The arrows from the parallel lines? Yeah. No, it's just an arrow that determines direction. But if you have an arrow in one line and an arrow in another going the same direction, you have parallel lines. And since there's no arrow here, so there's no evidence of parallel lines, so Leah cannot use the theorem. All right, number 4. For any pair of angles formed by a transversal intersecting parallel lines, what are 2 possible relationships? Good. Congruent or supplementary. Nice job. Any questions that I can address for you guys? All right, homework is on Delta Math today. Tomorrow it's on Savas. Huh?
I learned more.
No, like, yeah, exactly.
I learned so much
Like,
more
before
from
test,
Delta
you should
Math.
class like Delta Math because I like go over
Delta
the
Math is good
questions.
for studying, but Savas is better for homework.
Yeah, the problem is like your test questions come from the publisher. So you don't want to not do publisher questions. You won't be
But
prepared.
we should have like some short type of study
No, I don't
from
say
the
Savas.
public.
The other one.
That's what we give you. That's what the reviews for the test.
Yeah.
I gave you that to review. We give you the reviews for the test. Those are from the publisher too.
If you think any of us learned from the Savas, you agree.
No,
None
I
of us
don't.
learned
No,
from the
Savas. It's good practice.
I don't.
Who lied to you?
Stop.
He's lying to you because he gets the answers after.
Guys. Bottom line is, I didn't choose the curriculum. I would have went with something else.
Yeah, but,
But
What happened if you didn't realize?
no, I can't because it's all based off of a topic test that I did not create. Anyway, those who watching at home, have a great day. I think we're done now.